Hello, my name is Christopher Cotto, and welcome to Visualizing Linear Relationships using Desmos. In this lesson, we will explore how an interactive visual tool called Desmos can deepen mathematical reasoning. Rather than just simply plotting equations, you will use Desmos to see how changes to equations directly affect graphs, which helps you build conceptual understanding of the slope and y-intercept. Let's get started. Lesson description and objectives. This lesson will demonstrate how Desmos can move you beyond graphing and to build that towards conceptual reasoning and real-world modeling. You will also experience how visualization supports higher order thinking. By the end of this lesson, you will be able to analyze how visual representations in Desmos support understanding of linear functions, explain how changes in variables enhance mathematical reasoning, and design a short Desmos activity that promotes exploration and discovery. Self-reflection. Before moving forward, take a moment to reflect on the question that is shown to you. How does visualizing linear relationships help you discover and develop deep mathematical understanding and reasoning? Think about your own experiences with learning linear relationships. This reflection activates prior knowledge and sets a purpose for exploring how visualization supports deeper understanding. Why visualization matters in mathematical reasoning. As you recognize in your self-reflection, you might have thought to yourself, how can visual tools be powerful for mathematics instruction, and how Desmos can specifically support mathematical reasoning and modeling? There are common issues when learning linear functions. For example, many students can graph equations correctly, but struggle to explain what the slope and y-intercept actually mean, or they confuse positive and negative slopes as well as their direction on a graph. Visualization tools like Desmos will help address these misconceptions by reducing cognitive load, supporting hypothesis testing, and providing immediate feedback. This moves you up to the Bloom's taxonomy ladder, which is from remembering formulas to analyzing patterns and creating models. What is Desmos? Desmos is an interactive online graphing tool that allows users to manipulate equations and instantly see results. Instead of passively following a teacher demonstration, you will explore, test ideas, revise your thinking, and receive immediate visual feedback. Also, Desmos encourages exploration and deeper engagement with mathematical concepts. Exploring linear functions through sliders. You will interact with a pre-built Desmos activity featuring sliders for slope and y-intercept with graphs and tables displayed simultaneously. Changes to the slope and y-intercept are immediately reflected on the graph, helping students understand how each component affects the line. To keep exploration purposeful and reduce extraneous cognitive load, built-in prompts will guide your thinking. An anchor example, y equals 2x plus 1, is introduced first, so you have a consistent reference point. As you move sliders, you will respond to questions such as, what happens to the graph when the slope increases or decreases? What changed? What stayed the same? Can you predict the graph before adjusting the slider? These prompts help you self-check your understanding and connect your observations directly to slope and y-intercept. Addressing common misconceptions. Desmos makes common misconceptions visible. Students can make mistakes, like believing that a larger number does not always mean a steeper slope, that positive and negative slopes change direction, and that adjusting the y-intercept shifts the line without affecting the steepness of the line. Visualization in Desmos helps you correct these misunderstandings by making linear relationships visible and interactive. Collaborative discussion. You will discuss your observations in small groups. The guiding questions that are shown to you focuses on the intention of why Desmos works, not just simply how to use the tool. This discussion encourages critical thinking and strengthens conceptual understanding. Design a Desmos activity. You will design a short Desmos activity focused on linear functions. The activity must include at least one interactive element, either a slider or table, promote exploration, and target higher order thinking. This shifts you into the creator role, reinforcing meaningful technology integration. Lesson takeaway. In conclusion, you will answer a short prompt reflecting on how visualization changed your understanding of linear relationships. This final task reinforces the lesson's key message, which is that interactive visuals support deeper reasoning, not just simply correct answers. References. These sources support the lesson's instructional design, including research on visual learning, Bloom's taxonomy in mathematics, and effective use of Desmos for multiple representations. I hope this lesson was meaningful to you. Thank you so much for listening.